Hey everybody! We are back in my shop, as always, on my series where I take a business that's not making money yet and try to make it make money. My goal is to hit a revenue level of $100,000 a year. Now that's revenue, not profit. And I have about 50 weeks worth of money saved up to get to that point. Though of course if I spend money, that then eats into my time that I have remaining. The last couple of days I've probably looked and sounded really tired, and that's because I have been. My daughter, my youngest one, who's just 1 year old, has been sick and not sleeping through the night and at all. She's been up every half an hour for, the whole night. And so I just have not slept lately. But last night she did sleep and I slept in this morning and I'm feeling way better. We did find out what was wrong with her. She had COVID. My wife and I both tested negative, but we're playing it safe since we have someone in the family with COVID. I have this vision of a GIF on the Kickstarter campaign that has a robot that just repeatedly presses the carabiner, opening and closing it. Well, it'd be a GIF, so it'll just loop forever, and it would be a seamless looping GIF. That's my goal. In order to do that, I need to build a robot. I don't really want to spend money on this robot, and I have a bunch of pieces just laying around the shop. This came off of an old mill that I had that I never got running. It's a double-acting pneumatic cylinder. I think this will be the pushing power for our robot. And I have this valve on hand. Now this is just a normal solenoid. It's not really set up to run a pneumatic valve, it's not really set up to run a two-way pneumatic cylinder, but I think we can cheat and make it work. We're gonna do that by adding some sort of spring to push the cylinder back up in, and actually even the carabiner itself might be a good enough spring. And then we're gonna use this little fitting and valve here to make the cylinder self-exhausting. The solenoid will send this just a pulse of air, half a second long or whatever, and there will be a small leak coming out of this valve here. So the pulse of air will extend the cylinder, and as long as the outside air source is on, this will push down. But then once the air turns off, it'll all slowly leak out of here as the spring pushes this back up, getting it ready for the next stroke. The one thing I don't have on hand is a timing relay to control the logic of this. We may be able to do this with a limit switch, or we may need to buy a real relay. That's, I think, the only thing that we might have to buy here. Let's get started by testing my pneumatics just to make sure this stuff all works. Okay, so we have a piece of tube here. We'll put that into there. We'll close that valve. I have this little adapter. Retract that cylinder. All right, what happens if we just give this a little air? All right, cylinder goes out, so that works at least. Okay, now what happens if we give this a little bit of a leak? It still goes out. Heck, if I open that valve all the way, it still opens, though probably not with much force. Let's test how much force it's giving us. And then disconnect the air. Okay, so that was enough force where I couldn't compress this by hand. But now I can. Out of curiosity, if I close this valve and give this a little bit of air, can I? Oh, of course I can close it because this is not sealed. Yeah, doesn't matter. Okay. So our pneumatic system, at least in theory, works here. Now we need a mounting plate for all of this stuff. So something like this should work. We have two uprights, and then we have a top plate and a bottom plate. And on the bottom plate, we'll put a way to mount the carabiner, and then on the top plate, we will mount the cylinder. I just had a slightly better idea. Instead of using these blocks of aluminum as the upright, we can use these little smooth steel rods that were stolen from a 3D printer, and basically have those on a base, and then have a sliding part to adjust the height that rides up and down them. That way, when you're looking at this in a picture, because again, the real goal here is marketing, maybe not necessarily testing. But when you're looking at it in a picture, it'll be a lot more sparse. It'll bring more focus onto the cylinder and less focus on the frame itself. Plus, it'll be easier to make, because now we only need a top and a bottom frame. Though to make the bottom more stable, I think I'm going to use this hunk of aluminum that I've had sitting around forever. CAD time. This is our basic robot design. We have a base, we have 2 of these vertical rods, and then we have a carriage that goes across the top. This can slide up and down to adjust the height of the cylinder, and then down here we just have some holes for mounting things. This is totally unnecessary, but it makes me happy. I put a fixture plate style grid of squares in there, or grid of threaded holes, not squares. And that'll give me options of mounting different things in the future, and we'll figure out how to mount the carabiner later. I just want to get started on the rest of this first. The carriage just has some set screws here in the back that you can't see for holding it in place, and then a mounting place for the pneumatic cylinder. I wanted this to look nice and professional for the GIF, so I will be powder coating these, and I gave them some just nice rounded edges and chamfers and stuff, because I want them to look fairly pretty. The cam for the base is done. I just have a couple tools to set, and I need to cut my stock, and we should be good to go. The blade snagged my stock and it stopped it dead. I was probably pushing it a little bit too hard because I was, giving it a little extra oomph, and I cannot get it off. I can't even pick up the saw really because it tries to twist it. There we go. Let's not do that a second time. Have I ever talked about how these projects can snowball? Look at this. So right now for fixturing, I'm using this orange vise ZPS, which is mounted with these strap clamps. I also have a mod vise set up over here, but because of the way that I set this up, one of the strap clamps kind of sits on the tail end of this mod vise. Now, there is not enough room to put that piece of stock in my mod vise without moving it to somewhere else on the fixture plate. Okay, so that means I have to move my mod vise. And to move my mod vise, I have to move my 0-point system. Well, I've been meaning to redo this whole table anyway with like the real fixture plugs instead of these earplugs. So I was like, okay, I'll order some of these, some of the fixture plugs from Saunders Machine Works. And, well, while I'm doing that, I might as well move to the Saunders Machine Works pallet system because I'm not a huge fan of this for what I'm doing. It's just such a small area, even with the bigger pallets. I want to move to the Saunders Machine Works pallets. So, okay, I'm going to buy the fixture plugs and I'm going to buy the pallets. And well, I really like the mod vise, and it would be nice to have a second mod vise that I can move around on here, especially if I'm not going to be using the 0-point system anymore. I'm going to be using the pallets that already work with the Saunders Machine Works table. So I'll get a mod vise. And while I'm ordering all of that stuff, I might as well order some of the little serrated strips that go in the back of the mod vise jaws, because I've been missing those. And all of a sudden, I am spending about $650 at Saunders Machine Works. The part is set up and ready to go. I just need to probe it in to define my work coordinate system. We are halfway through the part and it's going pretty well, though we've had to make a few small code changes. First of all, I had to reset my Z height on this a couple times to get the facing pass to clear off all of the stock. This stock is just not square and I happened to probe on a high point. Secondly, I got a little bit panicked when it was cutting down on these bores. It seemed like it was going to chip weld and break the tool. So I stopped it and kind of played around with the coolant a little bit and changed the feeds and speeds. And it was still scary, but it worked. And then lastly, I just had to stop it again and turn on the mist coolant for this drill. It was just cutting dry, and I think it would have chip welded too. Op 1 is done and looking awesome. So now I need to do what's probably going to be the hardest part of this part. I need to set the work coordinate system for the backside. The problem is once I put this in here, I lose all of my access for probing. So I need to probe it before I put the part in. My work coordinate system is going to be based on the back of this jaw right here, the top of this parallel, and the side of this 1, 2, 3 block. And it's done. There we go. Now there's definitely a mismatch between the Op 1 and the Op 2. It's very noticeable, but I'll try to blend that by hand. I need to dial in my probe a little bit better, I think. All right, so the first piece is done and sandblasted. Well, it was degreased until I started touching it, and just about ready for powder coating. But I'm gonna finish the other parts first and powder coat them all at the same time. But I'm out of time for today. So thank you guys for watching, and I'll see you in the next video.